Hi students, today we're going to graph inverses of trig functions. And I got us started by graphing the sine of theta. Let's find the y values. These are our 5 key angles. The sine of 0 is 0. The sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1, and sine of 2 pi is 0. And I plotted the points above in the graph, and of course that's what sine looks like. So we are discussing inverses today, and the symbol for inverse is, it looks like sine to the -1, but it is not red, sine to the -1. It's the inverse of sine. And we know from our study from Algebra 2 to find inverses, we merely flip-flop our t-table, which is why I did our table of values for us. So we're going to flip-flop the table. That would 0, 0 flip-flopped is still 0, 0. Pi over 2, 1 would be 1 pi over 2. And pi 0 would be 0 pi. And 3 pi over 2 -1 is -1 3 pi over 2. And 2 pi 0 is 0 2 pi. Now let's plot those points. Notice what I've done with my graph paper though. Not only do my xy values flip-flop, but my x-axis and my y-axis flip-flop. So I'm going to label this the x-axis and this the y-axis. And now we'll plot our points. So 0, 0, 0, 0. 1 pi over 2, 0 pi, -1 3 pi over 2, and 0 2 pi. And we could graph more, but in fact, let's graph one more. It would be -1 pi over 2. Okay. And now you'll notice that the inverse is not a function. And if you remember the horizontal line test from Algebra 2, if you draw a horizontal line and you pass through your original graph more than once, your inverse is not a function, the horizontal line test. So in order for it to be a function, we have to focus on a restricted domain. The restricted domain that we focus on is this portion of the graph right here. Those 3 points. So that would be -1, pi over 2, 0, 0, and 1 pi over 2. I could erase the green, but I'm not going to. But if we focus on that little snippet of the graph, it is a function. So we call this a restricted domain. In order for us to have a function, we have to restrict our domain. So our domain is going to be -1 to 1, and our range is going to be -pi over 2 to +pi over 2. All right, let's move on to, this is actually going to be important to us. Remember that that is sine's range. That's going to become important to us in a minute. So I've done cosine. I went ahead and graphed it. Now let's flip-flop the coordinates. 1, 0, 0, pi over 2, pi, -1 pi, 3 pi over 2, 0 becomes 0, 3 pi over 2, and 2 pi 1 becomes 1, 2 pi. Okay, let's plot those points. 1, 0, 0 pi over 2, -1 pi, 0, 3 pi over 2, and 1, 2 pi. And this is the inverse for cosine, which goes on forever and ever. But notice that it too is not a function. The original graph fails the horizontal line test, which means the inverse, cosine's inverse, will fail the vertical line test. So in order for it to be a function, we have to have a restricted domain, and we look at these key points. Those three, if we restrict our domain to -1 to 1, we do have a function in that restricted domain. Notice our range is 0 to pi. The range is 0 to pi. This is going to be important for us for cosine coming up. Okay, let's take a look at what does arc tangent or inverse tangent, arc sine or inverse sine, arc cosine or inverse cosine, what does that mean? Arc cosine or arc sine means that you will be finding the angle. This is what your calculator does when you use SOHCAHTOA and you're wanting to find the angle measure instead of a side. It's finding an angle. So as soon as I see arc, I say to myself, what angle has a cosine value of square root of 3 over 2? This is where your unit circle is very important. So what angles have a cosine value of square root of 3 over 2? That would be, I don't know if you can see that or not, that would be a 30, and the other one would be a 330, or I would prefer pi over 6, pi over 6, and 11 pi over 6. You're looking for, I always say, what angle has a cosine value of square root of 3 over 2. Okay, let's move on to the next one. We'll do a couple of these and then we'll move to a different section. This one's arc sine. So, and the way I've always done it is what angle has a sine value of square root of 3 over 2. Now, really, you guys are supposed to know your unit circle by heart. So if you don't, you need to go back and revisit it. So I look at what angles have a sine value of square root of 3 over 2. That is a 60 or pi over 3, and also a 120, 2 pi over 3. So we have pi over 3 and 2 pi over 3. All right, arc tangent, square root of 3 over 3. What angle has a tangent value of square root of 3 over 3? Well, that would be a 30, which is pi over 6, and that would also be a 210, or 7 pi over 6. All right, these are the same thing. They mean the same thing. They look a little different. They have inverse cosine. That's how you read it, inverse cosine. But it means what angle has a cosine value of 1/2. So cosine is my x value. What angles have an x value of 1/2? That is pi over 3 and 5 pi over 3. They have cosine values of 1/2. All right, let's move on to the principal values. Principal values, I like to refer to them as the preferred values. That's not the actual preferred value. The principal value is a preferred value, or the value where our restricted domain, remember I told you we were going to use the restricted domain for sine, for inverse sine, our restricted domain was from negative pi over 2 to positive pi over 2. So negative pi over 2 to positive pi over 2. So in other words, from here to here on this arc. So our answers have to be on that arc. Now up above we had two answers. When we get down here, most likely we'll only have one answer. Well, we will only have one answer. All right, arc cosine, square root of 3 over 2. What angle has a cosine value? Square root of 3 over 2 that is within this. That would be pi over 3. Pi over 6, my bad. And arc sine, square root of 3 over 2. What angle has a sine value? Square root of 3 over 2. That is, oh, I'm sorry. This is cosine. Cosine, that first one was cosine. Cosine's restricted range is 0 to pi. Cosine is 0 to pi. So 0 to pi. Where when we do cosine, we're looking for an angle that is on this arc. When we're doing a sine problem, we're looking for an angle that is on this arc, negative pi over 2 to positive pi over 2. It's like a number line. It has to be on the number line from negative 90 to positive 90. It's got to be on that number line. So for instance, you could not say 315 degrees, even though 315 is on the number line. You would have to use negative 45 degrees because negative 45 degrees is on the number line, just for instance. Okay. All right, so let's go back to the first one. Arc cosine, square root of 3 over 2, that would be 30, where your cosine value is square root of 3 over 2. And for cosine, we're looking at that upper half of the circle, and that is still correct. So I got lucky on that one. Yay. Arc sine. So now I want to use this circle, arc sine. What angle has a sine value of square root of 3 over 2 that's within that pink arc? That would be pi over 3. Let's move on. Arc tangent. Tangent and sine share the same restricted domain and range. Let me erase all that. Okay, arc tangent, square root of 3 over 3. So that would be right here at a 30, so pi over 6. These mean the same exact thing, just a different symbol. All right, we're going to talk about one more thing, and that is composition using principal values. When you do a composition problem, you'll always use principal values. So, composition, we're going to do one thing, then we're going to plug our answer into the next thing. So, like for instance on this one, we have arc sine 1/2. Start inside your inner parentheses. Start inside parentheses. What angle has a sine value of 1/2? So that would be pi over 6. Then you're going to find the cosine of pi over 6. The cosine of pi over 6 is square root of 3 over 2. Okay, another example, arc cosine. So we start inside, arc cosine, square root of 3 over 2. So that's asking you what angle has a cosine value of square root of 3 over 2. So that would be pi over 6, pi over 6. And now we're going to find the sine of pi over 6. The sine of pi over 6 is 1/2. The tangent of 1/2 arc sine 0. So let's do this first. So what angle has a sine value of 0 on the preferred or the principal value? That would be 0. 1/2 times 0 is 0. And then we're going to take the tangent of 0, which is 0. And I believe this is the last one. This is inverse sine, which is the same as arc sine. You say what angle has a sine value of 1/2 that lie